Hello, Chem 140 students. So I'm going to go ahead and go over what have been some of the more frequent problems, that I am seeing for this lab. Let me see if I can get everything to work here. Good. Okay, so the first thing I want to go over, and this was the last thing in the video that I asked you to watch for the lab. I went over this live with my class on Tuesday. And Wednesday, I know I'd asked you to watch the video, and if you didn't watch the video, you're probably certainly making mistakes. So, let me be very clear about what you're supposed to turn in. In this order, please. I want the complete ASA. Advanced Study Assignment. That is both pages, even though it says optional, because I've said we're doing the optional. And I want those done with correct significant figures. We should know how to do significant figures at this point. I then want the Part 1 data for the calibration curve. I'm not seeing too many mistakes on that. So far that's not a real point of concern for me. As for the mx plus, the y equals mx plus b, the slope and the y-intercept, go ahead and, you can use more significant digits than you need there for those. But when you solve, you're going to see that pretty much all the data points will have the same number of significant digits once you get into it. And I don't want to say what that number is, but we'll kind of see it here. Okay, I then want to have page 189 of the lab complete. Exclude anything that talks about method 2. We're only using method 1 here. So no method 2 at all. Okay. And then the first row only. Of page 189. Excuse me, page 190. And a page showing your work. For that. Neatly labeled. And paying careful attention to sig dates. Okay? So these are the items that you should be submitting, again, in that order for experiment 23. Some other issues that I'm noticing as far as significant figures and things like that. As I emailed you rather disgruntledly a little while ago, a lot of you are making mistakes on filling in the or calculating the concentrations. You know that the line gives you a formula in the form y equals mx plus b, correct? And in this particular case, y is the concentrations, is the absorbance, and x is the concentration. So that's the molarity, okay? Now, what you want to be able to do is resolve that. So, of course, just using algebra here, we would have mx equals y minus b, which is then solved as x equals y minus b over m. you want to be absolutely sure when you put that into a calculator that that implies that there needs to be parentheses around there. Okay? So, for example, suppose that M is 4,500 and suppose that B is 0.035. It's not, but just suppose for a moment that that's what they are. Then you would now have the form X, which is concentration, equals, we have Y, which is the absorbance, minus 0.035, or whatever the B value is, divided by the slope. Not rounded off to too many significant digits. I would keep 4 or 5 so that you have extra on that. Now, let me be very clear. What's going to happen in Excel or calculator if you don't put those parentheses in? If you don't use parentheses, then let's say the absorbance is 0.555. If you put it in without parentheses, like this, that is going to calculate this. That would give you 0.555 minus 0.035 over 4,500, which is clearly not what you're trying to get, right? Because we know that order of operations, it does division first. So this is the only division that occurs. And so then you're going to get values that are pretty far off. So make sure that you're putting it into the calculator or Excel correctly. The other problem that I'm noticing has to do with significant figures. First of all, a lot of you are not correctly adding the volumes as far as significant digits go on step 2 of the first page of the ASA. It says a student takes 5 milliliters of a certain molarity solution plus 3 milliliters of another solution and then 2 milliliters of water. And we should recognize that each of these goes to the hundredths place. And since it's addition, that means that when you add these, that's 10.00 ml. That should be pretty basic for everybody. But there's a number of you that are going, oh, well, these all have 3 sig digs, so it's 10 ml. Again, that's a really basic mistake, a Chem 120 mistake that you shouldn't be making. I'm getting a lot of people with just 10. So no. You need to do this correctly. We've been practicing forever. All right. The other problem, and this is one I know, I used to address this in 120, but I just kind of ran out of time and got frustrated when I was covering it. But it's something that might not be obvious. So let me be very clear about this. What if we did this? 5.00 times 10 to the minus 2 plus, let's say, 4.50 times 10 to the minus 4. Okay? What I'm noticing is a lot of people are saying, well, this goes to the hundredths place, and this goes to the hundredths place, So I'll do the addition in my calculator, and then I'll round to the hundredths place of whatever it gives me. And that is totally wrong. Okay? They have to go to the same decimal place. And the thing is, because of the 10 to the minus 2 and the 10 to the minus 4, this isn't really the hundredths place. That's the 10,000ths place. Okay? Let me prove this. So let's rewrite this. So this is 0.0500. That's why that last zero is in the 10,000ths place, in reality, because of the 10 to the minus 2. Plus 0.0000450. Aha! So we see that they don't go to the same decimal places. So if you were to add this, that would be 0.050450, which rounds to 0.0505, which is 5.05 times 10 to the minus 2. 3 significant figures, as we see. So how do we save time on these kinds of problems? Very simple. You should always rewrite these kinds of questions so they have the same power of 10. And I recommend, because it'll always work out better this way, to make them the highest power of 10 in the addition or subtraction. So if this is negative 2 and this is negative 4, negative 2 is higher. So rewrite these questions as 5.00 times 10 to the negative 2 plus, now if we want 10 to the negative 2, that means I'm going to have to do what? Well, 10 to the negative 2 is 100 times larger. So I have to make this number 100 times smaller. I need to move the decimal 2 to the left. Now, since they have this same power of 10, we can go ahead and follow the significant digit rules just like we normally would. So when you add this, this would be, again, 5.0, what would that be, 450 times 10 to the minus 2, and then looking at the sigdigs, this ends in the hundredths place as written, this ends in the 10,000ths place as written, so we have to go to the hundredths place as written, which would be 5.05 times 10 to the minus 2. Okay? So you need to be very careful about this on the ASA. I will tell you that for the concentrations that you're getting on page 190, those should all have 3 significant figures. Hold on one second. Sorry, that's page 189. Of course, they then go on to page 190. And then what you should find on the first row of page 190 is if you get the significant figures right on the first row, they're going to all follow the same pattern on the subsequent rows. Okay? So they're really, I'm quite sure there is no change in any of those. So if you get them right on the first row, you'll have them right later on. You don't have to be as careful so long as you're careful the first time around. Now remember, the steps for calculating the first row of page 190 are almost identical to what's, in fact, I think they are identical to what you're doing on the advanced study assignment. That's the whole point of the advanced study assignment, is to get you so that you can do the calculations. You're just following those forms exactly. So that's kind of what I wanted to go over here in terms of the problems that I've been seeing. So one more time, you submit the complete ASA, both pages complete with the correct significant figures. You do the thing called optional because that's part of the assignment. Part 1, data for the calibration curve. Again, paying attention to significant figures. So far I haven't seen any mistakes on the Excel part of that, which kind of surprised me. That's where I thought people would have a hard time, but they are not. Again, page 189 of the lab report complete. Nothing with method 2, please. And then the first row only of page 190, a page showing your work. I don't need the rest, and in all likelihood, if you make a mistake anywhere on the first row, you'll probably have mistakes all the way down. And that's why I wanted only the first row. Okay, so that gives you something to think about. This is Saturday. This is due tomorrow night by 11:59 p.m. Please pay very, very careful attention to all this stuff. And I know you're studying for the exam too, but this kind of stuff should reinforce it, because these kinds of calculations appear throughout chemistry, and you don't want to be making significant figures errors everywhere. All right, guys, so please finish those and submit them as soon as possible. Thank you.